Hello everyone, welcome to my presentation using multimodal large language models to break CAPTCHA. I am Priya Shanmugasundaram and I picked the project CAPTCHA cracking and I want to use generative AI methods to be able to crack CAPTCHA. CAPTCHAs are basically a security mechanism that are used by websites and applications to distinguish between human users and automated bots so that they can prevent spam, abuse, and unauthorized access. There are different type of captchas: text-based captchas, image-based captchas, audio captchas, video captchas. So text-based captchas are basically users must enter distorted characters that are present in an image. These characters can be alphabets or numerals. And the second thing is image-based captcha, where the users must select images based on a given prompt. So there's a matrix of multiple images and users have to come up and select those images that match the prompt. So we only focus on the text-based captchas and image-based captchas for our project. So we want to perform captcha cracking using multimodal large language models. We want to study the ability of proprietary and open source models in cracking both text and image type captchas. So, multimodal large language models. Multimodal large language models are AI models that can process content across multiple modalities like images, text, audio, and video, etc. They can handle multimodal inputs, perform cross modal learning, where they learn these inputs from different modalities in a shared space and can improve context understanding. So, how do these multimodal large language models work? So, there is an image and text given as input to the model, which are first encoded using image and text encoders. These encodings are nothing but number representations of the input. So, they are just a high dimensional representation in terms of a matrix of the input image or text. And there is a structure called the projector, which basically maps the image encodings to the text encoding space. And once these different modality inputs are mapped to the same encoding space, they are passed into the large language model together, which then uses an autoregressive loss to train and produces as output a text. So there are different multimodal large language models available right now. The main two factions are the open source models and the proprietary models. So in proprietary models, we have very good models like the GPT-4 series by OpenAI and Claude by the Anthropic. And we also have Lava, which is an open source model sort of created by researchers to counter the proprietary multimodal models. So our goal is to give as input a captcha image and a task description in the form of text, which sort of asks the model to help us in breaking the captcha by identifying the code. And we want our model to give as output this captcha code present in the image. So, how do we do this? So, in this, we have taken two different approaches. For proprietary models, since we do not have access to their weights, we leverage prompt engineering and just querying these models to assess their security aspects and also understand their ability to withstand jailbreaking. And since open source models have subpar performance levels in comparison to the closed source model from OpenAI and Anthropic, we use in context learning and fine tuning for a few epochs to train the open source models for CAPTCHA cracking. So we have used Lava as the open source model that we will study and train. And for the closed source models, we use OpenAI's ChatGPT 4V and Anthropic's Claude to study their security aspects. So for our model training of Lava, for the data set that we use is the CAPTCHA data, which is a 1.3 million CAPTCHA image and text pair as shown here. So it has different images and also the corresponding CAPTCHA code in text. So what we do is we use the Lava 1.57b model to perform quantized LoRa training for 2 epochs, which comes to around 2 hours, where the projector and the large language model are actively being trained according to autoregressive laws. And then the model learns to predict or like come up with a captcha for a given image and a corresponding task description. So now let's quickly look into the demo. So we start off by looking at the proprietary models, the OpenAI ChatGPT 4V. So I have picked one of the images from our dataset, this particular image, which has a CAPTCHA code of 000294, and I feed it to ChatGPT, where ChatGPT directly gives me the text in the CAPTCHA or the code in the CAPTCHA as 000294 without having any sort of guardrails or saying anything about how it's not ethical to crack CAPTCHA codes. Moving on to the Claude model given by Anthropic, we see that for the same input image, we are able to see that Claude sort of tries to find out the characters but is not able to find out the characters, and also ends by saying that if you're not able to, you would need to enter the characters yourself, and if you're not able to, it's better to look for other alternative challenges like an audio challenge or so. So we will try to understand what is the reason for the difference between these two answers when we discuss the findings. But now let's quickly move on to our demo of our open source model. So first thing is the data set wrangling part. So we use our Hugging Face data set and use this Python file to create a JSNL file, which is the format in which the Lava model expects the input. So here we want the data to be stored in a dictionary format where we have the image path for every row mentioned, and we have the conversation stored as an array of dictionaries where we have the question along with the answer being the text label given by the dataset. Now, what is the next step? The next step is the fine tuning part. So, here in this script, as arguments, we pass the model checkpoint, the data that we want to use, the image folder, and also mention the encoder that we want to use and locations to store the projector after it has been trained, along with other hyperparameters like the batch size that we want to use, the learning rate, and the warm up ratio, etc. Now, after we mention these arguments, we call the train function from the train.py. So the train.py basically handles three main important things: the data, the training, and the model. So the first part is where it sets up the model. So it uses those arguments to sort of create the model objects for the image encoder, the projector, and the large language model. Then in the data handling part, it sort of uses the JSON file and loads that into the training. And in the training part, it loads the model in a quantized version because we want to perform quantized LoRa training. So we have a LoRa adapter that needs to be defined that is based on some hyperparameters, and we save some compute by training the model in the quantized state. So once this model has been trained for 2 epochs, which comes around like 10 to 12 hours, we end up with a final checkpoint, which we will use for inference. So for our inference, there are three settings in which we perform the inference. The first setting being the baseline open source model without any training. The second setting being the baseline open source model, but with some in context learning. In context learning is nothing but as part of my question, I will also give you some example question and answers to the model, and it has to use that question and answers examples as context and answer the question that I pose to it. And the third and final setting will be our trained model with the captcha data, which has not had any examples presented to it. So let's quickly look at that. So first setting where I will just call the baseline model. So it's the same image that I have fed to this, the same image that we fed to ChatGPT and Claude. So if we see here, there are no examples. It just asks what is the CAPTCHA code in the image, and the model says the image appears to be a CAPTCHA code, but it's not able to infer it because it's not clear. So let's try to see if in context learning has any impact on the learning or the ability for it to crack the CAPTCHA. This is again just the baseline model with a few more examples into the input. So here it has a few examples. So if you see here, this is example number one, where I have a question asking it about the characters in the image, where the answer is it's a low resolution captcha image with the text, the captcha code. Similarly, I have another captcha code here, another example here. And the third part is the question. So, what is the captcha code in the image? It again says it is not clear. So, the model is not able to use these examples to perform better. So, now we will load our model with no examples to see if it is able to perform better and crack the captcha. So this model has been trained using our captcha data, and then we load that checkpoint which we obtain after training. So here it does not have any examples, so it's just the question what is the captcha code in the image, and it says the captcha code in the image is 000294, which is correct. Now let's quickly look at the findings. So, existing open source large language models can be easily jailbroken. Prime example is ChatGPT, which did not have any guardrails. It did not present any resistance to us feeding it a captcha image and asking it for the code. And they can easily be used for unethical activities by leveraging prompt engineering. There are examples where you could ask it, saying you're asking for research, and it would help you. And the second thing being with good demonstration data, like the data that we had, and enough compute, fine tuning and in context learning can be used to develop offline assistants like open source assistants that can perform such unethical activities, such captcha cracking assistants, like the one that we fine tuned and trained, which was able to give us the correct captcha. Our project only deals with image and text based captchas, but there are other open source multimodal models that excel at audio and video modalities. So these can also be adopted to crack captchas of increasing difficulty and complexity, like audio captchas or video captchas, easily. So, to conclude, right now, ready to go solutions are not available for this particular task, especially because the field itself is rapidly changing. But one of the reasons that we saw a difference between OpenAI's answer and Claude's answer was Claude model has been trained on using constitutional AI based training, where the data that it has been trained on has attributes of harmfulness and harmlessness, helpfulness and harmlessness. So, helpfulness basically is what most assistants optimize for, where they just want the model to answer as good as possible to the query with a very helpful response. But Claude also incorporates harmlessness as one of the key metrics, where apart from being just helpful, the answer should also be harmless. So because of that, Claude is able to present a more mature response to our request. And LLMs with pure text based inputs and outputs, like Llama, for example, might be able to exhibit more safety related behavior, because the safety related training that has been done on any large language model is seen to be replaced due to introduction of a new modality. So there is again a requirement for it to be trained using safety specific data if we are using a multiple modality as input. So this has been seen in a few studies. So this is something I found very interesting. Thank you.